How many of you looked at a newspaper this morning? Did you see? Right here it says, hunting the galaxy for planets. This is the New York Times. And front page. And finding 1,235 contenders. This is for planets, right? So the first couple of times that we gave this course, when David and I gave it, we had Jeff Marcy from the astronomy department come over here and tell us about hunting for extraterrestrial planets. And he told us all about it because he's the guy that's finding them. And right now, David, who used to be the GSI for this course, is doing the same thing for Jeff Marcy's course. So he's writing and knows what's going on. So I think you've all met David, but David, spend a few minutes and just tell us about it. And I think bring in Paul, hold up your hand, because Paul was involved in finding out about this. This is sort of something that's so exciting, we have to insert it here. Then we'll get back to what we were planning to do. Go for it.
So Jeff Marcy is our colleague in the astronomy department here, and he rose to fame in the mid-1990s by being the first person, or one of the first people, to look into the concept of things called exoplanets, EXO planets. And so these exoplanets are planets that are not in our solar system, but are actually orbiting other stars. Think about that. These are planets orbiting other stars. These are other solar systems where maybe ET lives. And so when you think about this concept, looking for another planet around another star, it doesn't seem that bad. You just point a telescope at it, and you look for a planet, right? The problem is that for all but a handful of stars, we only see them as a single point of light. Like, you can't actually resolve that this is a disk or anything like that. And the problems have been worse for planets. Except for one report last year that actually a grad student in this department was in, we've never actually directly visualized a planet around a different star. And so Jeff became famous because he used a technique, a very, very clever technique, to look for stars in other solar systems. And so if you think about a solar system, if you have the sun here, and let's say a Jupiter-sized object somewhere out here. As Jupiter revolves around the sun, or as Jupiter makes an orbit, it turns out that the orbit's not just the sun stays in one place and Jupiter actually orbits. What happens is that these guys rotate and revolve around the center of mass, which might be right here. It'd be as if you took the sun and Jupiter and put it on a stick and tried to balance it. The sun's really heavy. Jupiter is not very heavy, but they balance somewhere over here. And so when Jupiter's at one point of its orbit, the sun might be right here. Half a year later, when Jupiter's on this side of the orbit, the sun will actually move out to here. And so by looking at, or around a different solar system, you'll actually see this star kind of move this way a little bit, then move back this way, and this way. And so as observers, way out here, kind of looking in this direction, we can't really see this motion. But what we can see is a light coming from this star, 50 or 100 or 1,000 light years away. And it turns out that this velocity is enough to, as the star is moving slightly away, it redshifts it a little bit. As this star is moving a little bit closer, it blue shifts it. Redshift, blue shift. This exact same concept that you learned about when you talked about the Big Bang and the cosmic microwave background. And so Jeff became famous by just looking at subtle variations in the spectra coming off these very distant stars, and seeing that these variations imply that there were Jupiter-sized objects around stars. So it turns out that this works for really large objects because the center of mass of the system kind of causes this variation. But for Earth-sized objects, it doesn't quite work. So a few years ago, they sent up a new satellite called the Kepler satellite. And the Kepler satellite, which is the one that's in the news, actually works by looking out at a star. And even though we only see it as a point, this star, if it has a planet rotating around it, you can imagine the planet's coming around, and at some point the planet might, by chance, pass in front of the star. And as this happens, the light coming from the star will be reduced by a very, very small amount. Usually for an Earth-sized object, it's about 0.1%. And so what happens is the satellite, this Kepler satellite that's in orbit, through a period of months, what you'll see is light coming from a star will be pretty constant, so this is time. This is brightness. The light coming from the star will be constant, and then all of a sudden, it will kind of drop down for a little bit and stay low, and then the brightness will increase. And what it's seeing here, what this Kepler satellite is seeing, is basically, it's seeing an eclipse of this star, a partial eclipse of this star from 1,000 light years away. And so this new data set over here just came out, and this is 1,235 examples of stars that actually have this going on. And in particular, Jeff's new report from here is they actually found a single star with 6 planets orbiting around it. And so basically, you can imagine if one planet orbiting a star kind of does this one little hump, you might have a second hump kind of dropping down like that, and then maybe a third one like that. And each of these would be a planet that's orbiting the star that's blocking 0.1% of the light that's coming from that star. And so for big history, it's kind of neat because for years everyone thought that, these planets that we're seeing, or was the solar system unique? Are there planets around other stars? And the answer is definitively yes. And then the second thing, the thing that I'm kind of impressing on my students is that big history is a history of everything, including the future. And so think about it. 1,000 years from now, these discoveries that we're learning about right here, these 1,235 contenders, your grandchildren's grandchildren's grandchildren to the 5th power will probably be exploring these and trying to figure out how to habitate these planets. So take a look at this, and it's kind of neat just seeing that a lot of this work has been done at Berkeley. Paul, did you have any experiences?
Well, basically, I took a lab with Jeff last semester, and we did both of those things. And we used the Kepler data that he had for the one on the left. The cool thing about it is that the idea is so simple that a lab full of undergraduates are able to do it and find the results.
So you're actually observing like light, and you see it
we were
drop
able
down?
to see the dips and calculate characteristics of the planet based on that.
So you actually have yourself discovered new planets, huh?
Well, I think the ones we were looking for may not have been directly with the program. We used Kepler data to do look for the red shifts back, or red and blue shifts back and forth. I don't think they gave us the actual data to actually find the planets, but we did with other data, and it's very simple to do. For undergraduate astrophysics people, it was easy to do.
Wow, that's really neat. Yeah.
And 2 quick questions. What happens if multiple planets pass at the same time? Does that just give it a bigger dip?
So I looked at the data that they had, and Paul, you might be able to correct me, but I think within a passage, you might actually see like a second dip. And so that would be a planet passing, that would be 2 planets kind of passing at the same time, possibly at different velocities.
Can it count for moons, or is it not that
And
high sensitive?
so what happened is,
Or asteroids?
I don't think it's actually released yet, but I overheard Jeff giving an interview 2 nights ago, and he actually said that they've used this method to detect moons also. In other words, this planet orbiting around will have a moon kind of orbiting around it, and that moon will block a little bit of the light also. And so that's not published yet, but yeah.
Is there any way to tell the distance from the star that the planet is?
Yeah, so you can get a sense of that by basically Kepler's laws. If you have a sense of the mass of the star, by how often these... Okay, so if you imagine a planet orbiting, right? If you see a dip here, 3 months later you see a dip, 3 months later you see a dip, something like that, you'll know that the orbital period is 3 months. And just from that alone, you can actually derive the distance from a star. So, and the important thing to note about this data is they're only releasing, this is 1,200 planets after 4 months of observation. And so I think this mission is supposed to last 3 or 4 years, and so this is just the beginning of kind of actually the quote from the New York Times is great. Astronomers have cracked the Milky Way like a piñata, and planets are now pouring out so fast that they do not know what to do with all of them. And so you can imagine that naming these things, right, in the solar system, we named them after Roman gods, and so I think even the pantheon of Roman gods is not large enough to name 1,200 planets. So it'll be interesting to see what happens.
I think one thing that's interesting, David mentioned this is only 4 months of data. Well, you know, it takes the Earth a whole year to go around the Sun. So if there were an Earth-like planet at Earth-like distance around another star, you might just have possibly seen it make one eclipse, but it hasn't gone around yet. So they're really looking at the stuff that's in close.
Yeah.
Josh?
In the Chronicle, it says that the telescope is only surveying 1/400th of the spacecraft's field of view in the visible sky.
Yeah, so 1/400th of the sky, and I think it's surveying 150,000 planets. And so you can think of, 150,000 stars it's surveying. So multiply 150,000 by 400, and basically the number of planets in the universe is like the number of grains of sand on beaches. You know, yeah. So yeah.
Yeah. How long ago did these orbits happen? Being that the light is coming to us from so many light years away.
Yeah. So the one planet that Jeff has the paper on that was released today, that one's 2,000 light years away. So, in other words, we're seeing these orbits as they were 2,000 years ago. For most of this work, I think the planets have been ranging somewhere. I think they ranged up to about 4,000 light years. So, but none of these, strikingly, are planets that are or stars that are 4 light years away, which is the closest star. So, we're definitely going to have to develop a new technology to get out there, but I think we will. So.
Well, David, thank you so much. That was a great presentation. Really appreciate it. Thank you. We just couldn't resist bringing that in. Oh, Ryan.
I thought I'd give a plug for, not necessarily for the New York Times, but it's worth checking out the popular news outlets. They will, you don't have to go and read all of the primary literature. If you really want to know the story, right, you would pull that original paper and read the original paper, but that requires a time and dedication to do it, but it also requires you have the vocabulary to understand that paper, etc. But the really good popular news outlets, the New York Times is a great one, and every Tuesday they have a special section called the Science Times, and it's available free online, and you can read all about the kind of biggest, sexiest science happenings in the last week, and if something makes the Science Times, you can guarantee that it's a big deal. It's probably published in Science or Nature, or it's on something that is very fluffy and lovable. Somebody will do the genetics of penguins or something. It'll be in there. But regardless, it's something that you have access to, and it doesn't require a ton of specialized information. You can pick up a bunch of good stories that way, and if you're interested, then you can go read the primary literature that's behind that. The New York Times Online is going to start charging in the near future, so I recommend if you want to do this, you do it soon. You can pay for it.
Great. Okay, so exciting things going on all the time, and when you think about big history, and I sort of blithely say, this is the history of everything. Well, remember, it's only the history of everything that we have any possibility of knowing about, because we don't know about the queens and kings on that planet that's just been discovered out there that was 2,000 years ago. And think about how many planets there are. So it's really the history of anything we have the chance of learning about. Maybe in the future when, as David said, your descendants from 30 or 40 generations down may be exploring that. They may be actually out in the halls of the queen and king of whatever that planet is, reading the archives and maybe they'll have a chance to learn things about history that we don't yet have a chance. But keep that in mind. Okay, so you've heard PowerPoint talks. You've heard mind map talks. So there's another thing we'll do in this class from time to time, and that's just kind of talk informally. So this is an unscripted discussion with you that Ryan and David are going to help me with, and we're going to talk with you about this whole process of doing research, like you're going to do in your research paper. So just to find out, for how many of you is this idea of doing a research paper in a class familiar? How many of you have done this sort of thing before? Some have. Anybody who hasn't yet? Okay, well this is great. You've got to start. Okay, well, you're about to do it for the first time. Okay. So we're going to talk about that today, but what I wanted to do is to say that later in the class I'm going to pass out a little thing here, and it's going to say, in a phrase or a title or a few words, what is your current thinking about the topic on which you will do your research for this, your research project for this class. So the idea here is to get a sort of a view of where everybody is in this process. So how many of you at this point have a pretty good idea what you want to do your research project on? How many do not? Okay, about half and half. That's reasonable. So if you are in the second group that have not yet decided, be thinking about it as we talk today, because we're going to talk about choosing research projects, we're going to talk about doing research projects, and so the best thing for you to do is I kind of have in the back of your mind, what might you do it on? If you have no idea, zero idea, here's a good thing to think about. What do you really like to do? Is there a place you really like to go to? Is there some kind of music you really enjoy? Because that may be a good thing to do it on. We did some of this in the group office hours yesterday and got several people on track. And so maybe by the end of the time you will have thought, yeah, I want to do it on, what I really like is spaghetti al tartufo. I want to know all about truffles, right? Okay. And so do be thinking about that, and we'll maybe as we go on toward the end, maybe we'll get somebody who's not too shy who would like to volunteer to do what we did in the group discussions yesterday, which was just to walk somebody through it and say, what you have no idea. Well, let's figure out what it would be. And maybe if we get somebody who'd like to volunteer for that, then the rest of you can see the process and it will help you think about it. So Ryan and David, come on up and let's do an informal sort of thing. I have shall I pass this out first? You haven't seen this yet, have you? This is a highly prepared section, you can see. Tell you what, why don't we pass these out now and let you read just the first part, which is about historical mindedness. Just do that, and that will be that. And then there's more of it later that we'll talk about. But let's just do this now, and it'll give everybody a chance to have something in their mind to be thinking about.
Walter, while you're doing that, maybe you could say a couple words about what you want to take away from the reading that.
Oh yes, I'm sorry. Yeah, I sent. Ryan reminded me. I put some articles on BSpace for you to look at, and if you look on the class schedule that I handed out earlier, you'll see which things you're supposed to read, and read them about the time. I mean, I'm not going to be fussy about whether you read them before the class or after the class, but about the time of the class, you should be reading those things. See, we have enough to go around. Maybe you guys could share that for now. Pass it down.
You can ask questions.
Pardon? Yeah, let's let everybody take a moment just to read the thing about historical mindedness. So I think that's a good thing to think. Just start by thinking about what it is to be historically minded. Okay. Yeah. And then we'll go into the research. I think I gave them all away, but I should try to get one so we have them. Is there one extra here that we could take up there? Since maybe you all can share that one. I'm sorry.
Sure.
We can make ourselves comfortable up here, you know?
Sure.
There, have a look at that, you guys, if you want. So you don't have to go on and read the research part of it yet. We'll get back to that. But I wanted to get you seriously thinking about what it means to be historically minded, to have the mental habit that when you encounter something that's interesting to you, you think, how did that come to be? What was the sequence of events that led to that? What is the history behind it? So maybe a good way to do that would be to ask each table to take a few minutes and get together and think of something that one of you or others of you have been curious about, and where you think there might be some advantage to looking into history. Why don't you take just a few minutes, and we'll call you, pull yourselves together into your tables and see if you can think, and then we'll talk about what you do with that.
So, Walter, I was thinking, during the research project, by definition, is being historically minded.
Yeah, are there any?
Because, as you say, there's different like, you have a topic. I don't know. How do they work? So where do they start off with like continents? And that forces them to look outside of the narrow scope.
In cases that you might do a research project that you can't restore. If you talked about the nature of the immune system and music, you could talk about how it works and what are
Yes, so I see like good research like two aspects. One of them is analysis. Break down the pieces and put it back. And I think that doing that automatically is going to place into historical context. Automatically.
we all be right. I think say in geology we have people like Bill Beaver who are interested in the process and don't care very much about the history, but people like you.
I guess what I'm saying is that you can do that. It's just like
So I've been trying to encourage them to frame things in the form of a question where you have essentially testing the hypothesis. And so it'd be interesting to see if we can get some of these people.
also because of example, I don't know, we both done research.
I'd also like to talk about them thinking, I got to do this little research project for a class. But that's not really different in time. Somebody does research for a living. It's just, longer to do it.
I bet you guys start on sports. I think maybe see what they have for
Okay, how are you doing? I heard something about shoes up here close. So, this table here, you guys, what did you come up with an interesting topic to? Did you? Yeah.
I was thinking that the history of fractals would be really cool.
History of fractals. Okay. Fractals are we're going to see some later in the class. So you could look into who discovered the different fractals, couldn't you? And how the whole field of fractal art came to be. Yeah.
There's also like fractal technology, like cell phone antennas and stuff that's coming out. It makes it possible to read different frequencies in the same antenna.
Oh.
Stuff like that. So there's like different stuff going on with fractals than just like the equations.
I didn't know about that. I never heard of fractal antennas. Okay, so that's something. Who's this table? What did you guys come up with?
I've been backpacking in the Sierras since I was like 3 years old.
Yeah.
Something about the Sierras probably.
Something about the Sierras, sure. So there are questions you could ask yourself, like how did the Sierras come to be, which is a geological question, or how were they explored by people like John Muir and actually by Joseph LeConte, who was the founder of the geology department here, our present department, and he was a great friend of John Muir. They did a lot of trekking together, so you could find that thing out. Yeah, that'd be good. Yeah. How about you guys?
History of surfing.
Pardon? History of surfing. Okay.
The way waves are formed and possibly like how the moon affects tides and stuff like that.
Sure, you could bring in tides and the history of that. That would be a good one where you could tie together geological history, because the tides have diminished because the moon has been gradually moving farther away from the Earth. You could tie all that together and yeah, that'd be good. I got to hear about shoes. Tell me about shoes. History of shoes?
Yes. Well, I don't know, maybe stilettos, because shoes is very broad, but I don't know how far back to go.
Okay, I don't know if you heard that back there, but the history of shoes in general is too broad and might bring in horses, I suppose.
Oh, because we talked about cooking too, and how far we would go back on cooking and also
cooking.
Music. So
Okay.
Could we decide on where we want to start with the history of it?
Sure, yeah. So what you're doing in this project is not finding out the specific things that we ask you to find out. It's basically to increase your understanding of some topic that interests you, maybe so that you can speak in an interesting way about it to other people when you talk to them. And so it's really up to you to find out. You need to formulate your questions. I think you were going to say something about that, weren't you, Ron?
Sure, nice segue.
Yeah, I like that.
And, so we've, in my discussion, talked a couple of times about taking a topic that you're interested in, which is sometimes the hard part. Sometimes thinking, what am I interested in? What would I do, given all the time in the world? If I could retire tomorrow, if I were Bill Gates, if I were Mark Zuckerberg, I could retire tomorrow, and what would I do with my time in that case? What would I choose to learn about? And that might be a way. Maybe you decide I want to learn about shoes, and then you think, well, that's going to take too long, and I want to learn about stilettos in particular. That is so now you have a field, you have a broad topic that you're interested in, but then boiling that interest down into kind of a hard nugget that you can then work on is a tricky part. And so what we've been talking about in my discussion section is trying to make that into a question and having testable hypotheses that are potential answers to that question. And so that is how you go, I think, from saying, oh, I'm interested in shoes, to doing real research. I mean, I think that's what good research is collecting data in order to test hypotheses, and that's as true in the humanities as it is in the hard sciences.
Yeah, and I was thinking that I might give you guys an example, actually a couple examples about how one might go about doing this process. And so the one I was thinking about this morning has to do with boats. And let's say you're really interested in boats, similar to really interested in shoes. And now you could ask questions about boats. You could say, why do we have boats? You could ask questions, how do boats work? Now, these questions are okay, but the total spectrum of knowledge that's required to give a reasonable answer to that question is way beyond what you might be capable of gathering for this class. So what we do is we narrow it down. And we say, okay, I'm interested in boats, but now I'm actually really interested in, I don't know, cargo boats, let's say. And so if you're interested in cargo boats, now you can start making new questions. You can start saying, okay, how have cargo boats been important in the history of socio-political interactions between countries? Or, in fact, how have things like climate impacted how cargo shipping lanes have developed through time? And then also, how have those shipping lanes then impacted the foreign relations between countries that those shipping lanes connect? And so you can go on a series of questions that sort of cascade you through topics until you find one that you think you can grasp a hold of and actually gather enough information to formulate a reasonable paper. So in my research, the broad reaching question that I'm interested in is the origin of life. Now, you can phrase that as a question and say, what is the origin of life? And there's really almost no way to answer that question. And so what we have to do is we have to break it down and think about other ways to narrow down that topic. And so I take it and say, oh, well, I think that life might have started on surfaces, mineral surfaces. And now I'm dealing with a system that I can actually construct from my own. And whereas instead of just looking in books, which is what you guys are going to be doing, I can go into the lab and actually run experiments and create hypotheses. But just the same way that I create hypotheses and say, if I put an organic on a mineral, what happens? So too can you guys say, let's say go back to the boats and guess maybe the wind patterns in the Atlantic have influenced how trade has developed over time. That's a question that you can go and look up data to test that hypothesis. And so science, humanities, really it's the same process, building questions, building hypotheses, and then going and testing them.
I had a question last night in discussion that was, is this the research? Actually, I don't remember. I think it was Matt who asked, and I don't remember how you phrased it. And it was, do you remember? It was something like, hey, "Are we doing?"
Yeah, you said that we'd be talking about research, and I said, "Is it like research, like for a paper, or research like in the lab?"
Yeah, yeah, and it was kind of like research, like for this class, or real research. And so I thought that what I would like to do is to kind of try and convince you that there isn't a difference between those things. And so my example is I was when I was an undergrad at UCLA, I did a quarter at the Bodega Marine Lab in Bodega Bay. Maybe some of you have seen it. It's owned by the UC system. UC Davis runs it. And so while we're there, I found these there are these little tiny clams that are about that big. My mother calls them big sand because they're very small, and they come in two kinds. There are white ones and there are purple ones. And so I, just for whatever reason, I mean there are hundreds of species that live in Bodega Bay, but it seemed like a reasonable question to ask. Well, are these two different colors of the same species, or are these two different things that just happen to look very similar? Two different species, and that was a question that I became interested in as a result of being in a class there, and it ended up being my master's thesis. And it turns out what I ended up doing was kind of taking apart lots of these clams and kind of measuring the different traits of the shells, and I couldn't find any difference, and sketching the outsides of them and couldn't find any difference, and weighing them, couldn't find any difference. But then I looked up in the literature, and one of them had recently been described as a distinct species from the other one, which had been described 100 years earlier. And I thought, well, that's interesting, because I can't find any difference between them. How are they different species other than being purple and white? And what is a species? And is that good enough to be a different species? And then fortunately, I was in a lab that allowed me to use kind of very fine-grained tool of having DNA sequences available. So I generated DNA sequence from these two, and it turned out not only are they different species, but each of them houses this wide variety of genetic variation within the species, and there may be yet other species within the white clam, and yet other species within the purple clam. And so, at what point did that go from being kind of an idle question into research? And at what point was that research I was doing for a class, and what point did it become real research, if those are different things? And I don't think that they are. I think that the point at which you're doing real research is the point at which you are taking it seriously. If you are writing down what you're doing so that it's repeatable, so that you can come back to it and not lose your way, or somebody else can come back to it. If you're making sure that each step of the way what you're doing is right, that you are defensible, and that you wouldn't be embarrassed to hand that to somebody else and have them redo it and see if they would come up with the same answer, I think that's legitimate research. People publish papers as undergrads, and there's no reason that you can't.
I think those are really great points. And in fact, without reading it, you might just glance at the headings on here, because I was obviously thinking on the same same questions that Ryan and David were when I wrote this up. So I wrote down here that there are different levels of research. And so if you turn over to the second page, you'll see that the first one is, it says casual research. Poke around on Wikipedia to learn a little bit about a topic. I bet many of you do that already. In the sort of broad view, please don't read it now. If I just want this to get you to read it later. The beginning of a major research project is curiosity about something that maybe you don't know anything about yet. So the casual research would be the first step, when you're just beginning to find, am I really interested in that? Yeah, I think I am. I'd like to learn more about it. So then it goes on and it says that the next one is careful literature research. So now you're digging in, and this is the level that you guys will be doing in this class. You're digging in and finding out what other people have learned about it. You're trying to see what are the cool problems in it, and what have other people thought about it. And then maybe you become a graduate student, or maybe you do a senior honors thesis, and you want to find out some new information that nobody ever did before. And then you can go in the lab like David, you can go in the field like Ryan and collect information, go in the mountains like I do and collect geological things. Bring in new information that you'll use to make a contribution to the sum of human knowledge. But it's all sort of a sequence, from the first casual thing, gosh, I wonder how stiletto heels got made in the first place, right? And then maybe you dig deeply into it, and then you find out, we ought to do some experiments to see how safe these things are. What's the strength of a stiletto heel? Maybe we take it in the laboratory. I'm sure there's shoe companies that are doing that, making measurements in labs to see whether these things will hold up. So I think you can see this as a whole spectrum, a whole continuum. And you guys, I'm sure you go on Wikipedia and look up things that you don't know anything about just to find out a little bit about them. I do too. Great place to start. What you'll see in here is when you get into the second part, which is the serious literature research, then you got to move beyond Wikipedia and go find some books in the library. I'm going to be beating on you because I love libraries, and I think maybe students at this point don't have the habit of going to the library like we did before the web existed. And then the continuum leads on to where you find out more stuff. You get new data yourselves.
Can I add a point?
Sure.
So you mentioned, and you sort of made it seem as though adding new data or new information is done by collecting things in a lab or in the field or something like that. But I think also it's possible to add new information just by being in the library. Mm-hmm. And that is actually kind of the point of this class as well, in that it is possible to gather different perspectives on a topic that no one has ever gathered before, and never seen a certain angle of a topic before, and gain new important information and new important understanding about that topic. And that can all be done from your couch or in the library, reading books, writing things down, drawing connections. It still takes the rigor of the second part, not the casual, but the actual literature review research. But it doesn't necessarily have to be in the lab or something like that.
So who has a thought or a question or something to kind of get us on to the next point?
It's bold. It's going to take a brave person.
Oh, we got brave people.
Yeah.
Okay, Michelle is brave.
So before you mentioned how, let's say for boats and how the weather patterns influence trade for that. So what happens if you're, let's say, studying something like the origin of life, where you can't really say it serves the purpose, it's purpose that it serves. What are you trying to how do you formulate that statement? Say, this influenced the origin of life.
Are you asking for the purpose?
Or it's like what is your I guess how do you narrow it down and what's your core question? Or like,
Sure.
I guess you talked about the
I
organic.
could go in a little bit more specifics about that, sure. So like, the big broad thing is how did life evolve? Or how did life originate? And so I take my own knowledge and my own background and project that onto the question. And I know a lot about chemistry on surfaces and physics on surfaces. And I just know that already coming into it from taking classes, previous interests. And I know that most likely chemistry on the early Earth was happening on mineral surfaces. So I say perhaps it could be that some of these early reactions that are required to have life happen on mineral surfaces. So let me create an environment that mirrors what I think existed at the beginning of when life arose on Earth. Put in all those conditions, put in some of the organic molecules that I think might be taking part in metabolic cycles and things like that, in metabolisms of those early organisms, and see what happens using my own expertise. And the question that I end up asking is way more specific. The question that I'm asking really is, how do organic molecules change when they interact with zinc sulfide surfaces, when UV light is shining on those zinc sulfide surfaces? That is like the real
that's why
question.
scientific papers are boring.
Yes. But really, at the end of the day, when I find things about that, I'm really actually telling you how life could have arisen on this planet or other planets.
And that's why the abstract's important.
And that's why you read the Science Times.
Yeah.
Because it tells you about that stuff, and not so much about the boring stuff.
Yeah, so I think really good science writing, which we would like all of you to be able to do, is to take the thing about zinc sulfides and get that information across, but do it in a way that the reader can say, oh, I can see why that's super important for thinking about the origins of life on the planet. Because the title of the paper can't be zinc sulfides and yada yada, because if you're not interested in zinc sulfides in particular, you're never going to read that paper. But if the title of the paper is A Possible Origin of Life on the Planet Earth, slam dunk, the New York Times is calling you. Right? So it's a way of, it's a real skill set to be able to know why you're doing something on all of these different levels, and to keep track of all of those, and then to be able to not lose information content in translating from one to the other. And that actually is what the first letter home assignment is meant to do, is that you're meant to be able to kind of work on these different levels simultaneously.
Yeah, Ryan mentioned the abstract. I'm sure many of you have seen enough technical papers to know that there's this little thing in little paragraph in fine print up at the beginning, which sort of gives you what it summarizes the whole paper. That's you often is in very technical language. So one thing I would suggest to you guys is that when you come to a paper that you think you'd like to read, and you ought to find a few while you're doing this project, find a technical paper. I always start with the introduction, because if there's one place where the author is going to have written this stuff, yeah, most scientists are very proud of writing something that can't be understood by anyone other than the 20 or 30 people who work on the same topic they do. You know, and that's a little of an exaggeration, but an awful lot of scientific papers are really written for the few other specialists in the world who know about it. And if there's any place where that author is gonna kind of slack off on the jargon just a bit, it's going to be the introduction. So try starting with the introduction. Okay, Deborah.
You know, in trying to figure out how to follow the breadcrumbs to the place of rediscovery, can I just throw out just a thing? Okay, so I love to hike, and I come across what I've found to be radiolytic chert. I love these rocks. Okay.
What color?
Reddish.
Dark red.
Yeah, dark red in the marin.
Sure.
And I noticed that there's these outcrops of them, right? And you get cutouts where the trails are, and that there are places where they're there, and there's places that there aren't, and some of them are rather large and incredibly impressive. And I've wondered about. So I took a geology class, and that's when I found out they were radiolated chert and that they're from spreading centers, right? Okay, so let's say I love that rock. I bring it down in my backpack. It's heavy too. And
Sharp and
yeah,
nasty.
sharp,
Yeah.
beautiful.
Yeah.
Don't put it down in the backpack.
It's hard, I don't know if you're supposed to be taking rocks, but.
Yeah.
So now let's say that's my topic. I mean, how do you even begin to?
That's like your broad topic. That's
Yeah.
like boats. Almost. It's a little bit more specific than just boats. It's not rocks.
It's like boats because both the boats and the radiolarian chert have crossed the Pacific Ocean to get to California. Yeah.
So now you really have to ask that topic the question.
Like, how did you get here?
Sure.
Yeah.
Yeah, right, exactly.
That's
and,
great, yeah.
And when you start pulling information from that, maybe you'll realize that you need to narrow it down. Maybe you realize you won't. I don't know too much about the story of these rocks, so I don't know if you're going to be able to take all that information and put it into a presentation or into a concise story.
So I could say, how did the radiolated chert get in the Marin headlands? That could be my question.
I think yes.
You could, but you might find that we know how it got in the Marin headlands, right? So if that happens, which I suspect we do,
That's good though.
But not everybody in the classroom does.
true.
Or
But
me.
if or you, but what? But I guess I would say if you get to a point where the question you originally asked is answered and you know the answer to that question, then what you'd like to do is kind of take one step further and say, okay, well, what don't we know yet about this, and what can I contribute to that? So what can I bring to the world that's new? What can I say about chert that no one else has ever known before? And I think for I don't know why there are different colors of chert, for example, and I don't personally know why that is, but I bet somebody does. And then maybe ask, well, what are the different distributions of where does green chert show up versus red chert along the California coast, and why is that? Are they associated with different kinds of rocks? And then what can we learn about those differential distributions that tells us something maybe about the history of the geology along the coast? And that way, even if somebody knows the difference, knows the answer of why does chert come in different colors, you might. That's I think what David was saying before about you're discovering an angle to talk about it that nobody's ever talked about it before, and you're thinking new thoughts.
But what if they have?
Well, then you find that then you go one step further than what we know.
It could also be as you're going through it, you realize that a lot of people in the history of California have been fascinated by this rock, and so now there's a whole different range of histories that you can delve into and how they've intersected with this rock as your history has intersected with this rock. And you can go that whole entire route as well. But that's you can do that with any topic, right?
You always get distracted along the way, and sometimes the distractions are more interesting
Sometimes
than the original
distractions
question.
lead to newer, better questions.
So I have an idea right now, and this is sort of a lead into it, but Deborah already knew something that she was interested. So yesterday in the group office hours, I asked Lindsay what she wanted to work on, and she didn't have any idea. She was just completely a blank. So we started working through it, and 15 or 20 minutes later, she had a project she was really excited about. So how many of you still don't have any idea of what you'd like to work on? Have you all figured out? Okay. So I wonder if there's anybody here who doesn't know what they'd like to work on, who is sufficiently unshy to be willing to kind of do what we did with Lindsay yesterday. And whoever is the volunteer will probably end up with a really great research topic, and then everybody else will see how you do it. And then if you are somebody who doesn't have a project yet, and you'd like to do this, you can hook up with the person next to you and do this thing together. So I wonder, is there anybody who really just doesn't know what they want to do it on and would like to kind of work through that process now and let everybody see? If you don't, that's okay, but it would be fun to try. Anybody? It worked with just a few people yesterday, so somebody?
I'll volunteer.
Okay, Josh. All right. So if Josh doesn't yet know what he's interested, what he wants to do his research project on, what we did yesterday in the discussion was to say, well, what do you like? What would be your favorite thing to do, or your favorite thing to your favorite place to go, or what's something that really you just like?
I like to play music.
Okay.
Should I say a couple different things?
Sure.
I like New England.
Mm-hmm.
And I have some historical interest in that area,
Uh-huh.
possibly. I'm interested in history of things that are surprising that I didn't know about.
Mm-hmm. Mm-hmm.
One of the things that crossed my mind was the role of women in American history, back in places where you don't hear
Mm-hmm.
about.
Uh-huh.
I bumped into that a little bit as a teacher, but I'd like to learn more about it.
Okay, well, we've got to start now because we know three things that interest Josh. History of women in our country and the role they've played, New England, and music. So let's take music. Okay, I know about Josh because he's a wonderful guitar player. We play music together. But so let's dig a little bit deeper. So what kind of musical styles or musical instruments do? And by the way, let me just say, keep in mind for yourself, these are the questions you can be asking yourself as you try to figure out what kind of project to work on, what topic to work. So what kind of music or instruments, Josh?
Well, I like play the guitar mostly, but also a little banjo and
Uh-huh.
piano,
Uh-huh.
that kind of stuff. But I like, one hand I like rock and roll,
Uh-huh.
electric music, and on the other hand I like acoustic, finger picking, kind of
Uh-huh.
bluegrass or folky kind of music.
Okay, which one of those should we ask Josh about? Pardon? Bluegrass. Okay. Deborah wants to know about bluegrass. That might, yeah, but maybe. Is there another thing we'd like to know about? Banjo. Okay, banjo. Let's think about so. So, what might you want to know historically if you were thinking about the banjo as you play it?
Maybe who sort of came up with what I imagine is the more modern kind of fast finger picking banjo.
Okay.
I could probably think of a name, but I mean more about that.
Uh-huh.
Where did it come from, and what was it like before that, and why was there this new fast style invented?
So banjos go back to African American slaves who were brought over here. I believe that's where the banjo first came from. It derives from African instruments. And by this way, this is not a setup. We didn't plan this. But so what Josh is talking about, that really fast picking that's done in bluegrass music. How many of you have heard that? So who's a name you associate with that? Earl Scruggs. So maybe then, Josh, what your question then is, how did Earl Scruggs come to play that really fast? What is it called? 3-finger style banjo playing?
I'm not sure.
Yeah. Uh-huh.
Fast banjo.
Really fast. Yeah. So you could look into that. How would you do that? How?
Besides going on the internet and fast banjo.
Yeah, you get.
Well, there's one resource that I think is really underused and that'll be useful for all of your projects. We have a music library on campus, and there are music librarians who work in the music library, and they just sit there all day. I mean, I'm sure they have other things to do. But they're really waiting for people to walk in and ask questions like, hey, how do I find out more about the evolution of the banjo picking styles in the 1930s and 40s? And that's their job.
Most departments on campus actually have their own libraries with their own librarians, also waiting for questions. So sort of you think one of your topics fits into the discipline of a single department.
And they love to hear from you.
They do.
You
They do.
make their day when you walk in the door. It's not they're doing nothing, but they literally do wait for people to walk in the door and ask questions that the reason they became research librarians is because they like doing research and they're happy to help you. So that might be a good place to start.
And I didn't know that. So
Yep.
that's
Yeah. And you might want to, you'd probably find out who was doing this before Earl Scruggs, who's is known as the father of this kind of music. Did Earl Scruggs make up fast banjo picking did he make it up out of himself, or were there other players who were kind of leading in that direction that Earl Scruggs learned from? So you could go into that, couldn't you? And
the music, the string instruments in the early 20th century are super interesting because you have this, you don't have standardization yet of all of the different instruments. And so you have 4-string banjos and 5-string banjos. You probably at some point have 3-string banjos and 6-string banjos. The necks could be this long or they could be this long. You get banjo ukuleles and banjo mandolins well into the 1920s. And we hadn't arrived at what we think of as the standard banjo yet. And I wonder if the physical evolution of the instrument had an influence on how it was played. It must have. And vice versa, where there are instruments that were made for particular players that enabled them to go faster or have better tone or whatever.
You know, it strikes it's not Earl Scruggs lived in the mid-20th century or so. I mean, I could just imagining wanting to go find people who played banjo, who knew him or his predecessors, and doing research in that way. And actually hear us.
So anybody have a question that they would contribute to Josh for his the sort of the way we've been doing? Michelle?
So when do you, I guess, jump out of the standard history of, like, let's say music in the Americas, or like in like American music, like from and then music in the history of music to something, let's say, more physical or more like chemistry, like I don't know. I mean, like, how do you broaden your
Well, in this example, one of the things that Walter mentioned was that, or no, Ryan mentioned that the shape of the banjo could actually have a significant impact on how it's played and the style that's developed. And then you can get into the entire mechanism of that and how that has developed, the physics of how that has developed, and the acoustics and whatnot. You could go well beyond music history and get much more into totally different regime, really.
But I think the difference between doing a report on the banjo, in which you're not asking a question, and research on the banjo, in which you're asking a question, preferably with testable hypotheses that you can kind of disprove along the way, is that difference between, is kind of the difference that you want to make in moving from report on history of the banjo to original research. So if the physical shape of the banjo, if that's our question, does the physical shape of the banjo impact the style? How do we test that?
Just as
maybe we're thinking about ways to test that.
Just as a sort of a sidelight that comes to mind, I'm sure many of you are interested in music. Some of you are probably interested in physics. You know that there's a great course in the physics department that's called the Physics of Music, and it explains what happens. When you pluck that string on the banjo and the sound comes out. Why are banjos loud? And it's taught, I believe, by Saul Perlmutter, who is the physicist who discovered that as the universe is expanding, it's expanding faster and faster. So if anybody is interested in that, that'd be a great thing to take. Josh?
There's a class called Music 29.
Yeah.
Music Now, and it looks at music morphology.
Uh-huh.
And, different things like that.
Yeah. Okay. So you see all the things there are that Josh could dig into, and at some point, you see what he's going to find is that he's asking a question, he's asked more and more questions, and he's gotten deeper and deeper into it. At some point, he's going to ask a question, and he can't find an answer for it. He can't find that anybody has looked at it before. And that's the point where you're in a position to start finding out new things yourself, to see, look into it and see what could the answer to my question be, because I can't find that anybody's ever done it before.
And at that point, you are the expert on that topic.
Mm-hmm.
You
Yeah.
are, and you know more about that very narrow thing than anybody else does in the world. And that's pretty cool. And it doesn't matter if you're 18 or if you're 65. You know, that's an ability you can. The only way to, the only qualification you need is the kind of dedication and curiosity to go after that. And I think that that's really nice. You don't need a license to be a researcher.
Yeah. So I want to take these last few minutes and talk about libraries, because the libraries have come up, and I want to give you a sense of the feeling that I have about libraries, and I hope this speaks to some of you. But you know, we can have conversation, all of us in this room, because we are contemporaries. That means that at least parts of our lives have overlapped, right? So we can actually talk physically with each other. Okay. But your first thought is that you can't talk with anybody who died before you were born, right? In a certain sense, that's true. You can't go out and have a regular conversation with them. And remember, we talked about how fast the past is receding, sort of at the speed of light, so that something that happened 100 years ago is the same as a star that's 100 light years away. It's this sort of this frightening rapidity with which the past is receding from us, and you think that completely isolates you, so you simply can't talk to anybody who lived a long time ago. I've gradually come to think that there is a way of getting around that you actually can have a conversation with somebody who is from a previous generation, somebody with whom you were not a contemporary. You know, you can have, you know, as a geologist, I can have a conversation with Alfred Wegener, who died before I was born. You can have a conversation with Copernicus or with Napoleon. There's a limit to it, because it only goes in one direction. But when I'm reading a wonderful book that was written by somebody hundreds of years ago, to my mind, that's a conversation. And sadly, I can't talk back to them, but they can talk to me and tell me what they were thinking about. And that's, to my mind, and I'm sorry if this is almost mystical, but that's the experience I have when I walk in the door of Doe Library over there, that great granite portal. I'm entering a place where I can have this conversation with people who died before I was born. And you see, I can't speak to them, but I can speak to the people in the future by writing a book like T-Rex or The Mountains of St. Francis that maybe somebody will read 200 years from now. Maybe they won't. But to my mind, that's what is so magical about libraries, and why I just can't get enough of them. They're my portal to conversations with people in the past. And I think a good way to close is just let me read you something here. It's at the end. Don't read it now. I'll read it afterwards. But this comes from a one-way conversation that I had with a colleague of mine, an Italian colleague, and his name is Niccolo Machiavelli, and he lived in the 16th century, and he really understands this thing that I'm talking about. Here's what he said. Wrote this in 1513. He said, "I go into the library, and as I cross the threshold, I cast off my everyday clothing, covered with filth and mud, and put on the costume of the royal court. Thus honorably clad, I enter into the classical court of the ancients. They welcome me warmly, and I feast on the nourishment for which I was born. One person's view of a library. John.
The point about the reference librarians at Cal is this, which is when, say, you or your graduate students want to know about Great American Church, those reference librarians have to call with a request from you to please find research sources, column A, B, and C, so that if Deborah walks in and asks, Regularian Church, what do you have on them? Those librarians will send her to the places they know are reliable because you asked for them. And that puts her a couple of miles ahead of where she'll be with Wikipedia.
Yeah. Absolutely, yeah. Wikipedia is a great place to start. It just isn't a good place to finish. Oh, yes, before you go, thank you. Would you each fill in here what your current thinking about your topic is and let us have it? Thanks for reminding me.